Yes.
All right. Welcome, everyone. My name is Jan Eglering. I'm one of the hosts for the Azure user group in Norway. Today, we have an exciting topic where we're going to talk about Azure machine learning and Azure Kubernetes Service together with Ambarish Ganguly, which we have joining us from India. Before we get started, I would like to few words from our sponsor today, Microsoft Norway. They have this free guide on how to get started with Azure ML. And they also have, as in previous meetings, a cool Microsoft branded backpack to share with today's winner of the best tech question. So feel free to pop questions in the chat, and we'll make sure to ask them to the presenter when it's needed. So feel free to sign up also for the Microsoft Azure Learner skill. So I will make sure to put the URLs in the chat. Okay, so let's get started. Ambarish, he's actually a NASA citizen scientist, TCS Utilities Data and Analytics Practice Lead, and Energy Trading and Risk Management Practice Lead. So he blogs at ambarishhg.github.io. So we follow this blog there. I'll make sure to put it in the chat. So Ambarish, I'll stop sharing. So feel free to get started, and thank you very much for joining us today.
Yes, thank you, Jan. It's a pleasure to talk with you all guys in Norway. So I just start sharing my screen. So today what we are going to talk about is Azure ML, Azure Kubernetes Service and model deployment. What I'll do is that I will keep the slides to a minimum, though I have a lot of slides, but I'll show you of how it is being done. So for that, I think the best way to learn anything is to do a case study. And the thing that we have chosen is a very simple thing. What we'll do is that we'll predict the quality of red wine given certain attributes. So there is a whole lot of attributes here. The intention is not to go deep into the business problem, but to understand of how we can leverage Azure ML for ML activities. And it is a very nice platform because I've been doing a lot of data science competitions, research, and so on and so forth, and also working in industry. You require a platform which helps, first of all, to record all your experiments and also to deploy seamlessly, and also it must be scalable. So Azure ML provides that, and so we'll see that in the subsequent slides. So what we'll do is that I have written a blog. I have put all the code in GitHub, which I'll share with you, and the slides are there. But what I've done is that I've executed the code, and all of it is in Azure portal. So we'll move in between slides and Azure portal so that it's less slide and more portal, more code and all these things. So it makes more friendly. So Azure, any model training is composed of three main parts, which I believe this is my way of thinking. One is the training, and then is the inference, and then is the deployment. Okay, so continue. So these are the steps. I'll not go to the steps. The first step is that you create a workspace in Azure ML. So what it means, it houses everything. It houses everything. So I've got my subscription ID, my tenant ID, and it creates a workspace and in a resource group, and the location I have put in central US. So what I've done is that I have executed the code in here. I've executed the code already, and you'll see that I have already got this in my portal. So I'll just go here, portal.azure.com. So this is the one that I created. This is a resource group. And what it does when it creates a resource group, it creates a host of things. It creates a registry, actually doesn't create the registry, it comes later. The Kubernetes service comes later. But this creates a workspace, insights, a key vault, and the storage account. So that is the thing. So it creates a whole lot of things when you create the workspace. So that is the house of everything. Okay, so once the workspace is created, so what we'll do is that machine learning requires data. Okay, so without data, we cannot do machine learning. So what it would do is that we would upload the data from our local machine into the workspace default data store. So when we execute this, it will execute it into the default data store. So before we go into the data store, so this is a workspace that it created. So I just launched the workspace here. So the workspace is this huge thing. So Azure ML workspace you see, but it has got a lot of things. It has got data sets, experiments, and all these. So here, what we did in this step is that we uploaded here actually. Okay, no, it's not there. We upload it into the data stores here. So this is a default data store, and this here, if I go here into this data store, let me go back to the portal, that becomes easier. Let me show you where it has done. So this is storage account, and within that, this is a default data store, and in the containers, so I did it through code, the code that I showed you, and what it does is that it puts wine data here. So these are the things. Now let's go back to the code here. So wine data, and it is putting all these files. These two files, the wine quality red data, these two files are there. So these two files are in this data store. So that is so we have created the workspace. So we have created the data set. So all that is there. So the next step, what we'll do is that now we'll just create a folder where we'll keep the training script. So this is just what should I say, housekeeping things. And then what we'll do is that we'll create the compute cluster. So why the compute cluster is needed is machine learning requires data that we have uploaded to that data store. What we are missing is a machine where it will run everything. So we make use of Azure to create a cluster so that we can run these machines. So here, these are the VM size. See, I am using an Azure bus, so I just made it standard D2V2. You can go ahead and have more powerful machines. You can use some min-max nodes and the max nodes to create more powerful machines here. So you have created the compute cluster. So that is the thing. You might hear some background noise because it's raining very heavily out here. So the next step is a training script. So the training script, I will not go into details, but what it essentially does is that we are creating a decision tree. Okay, so maybe We'll not talk about algorithms here. Maybe sometime later we'll talk about algorithms. This is a regression problem because you have got a set of attributes like this. You have got a set of attributes which are all numerical variables, and you are also trying to um, do a numerical variable which is 1 2 3 4 5 6 7. So this is a regression problem. I modeled it as a regression problem. So this we are using the decision tree. So the code is there. It uses a decision tree regressor, and I use a scalar to do cross-val. So maybe in one of the sessions we can go into depth of it. But this is a very simple scikit-learn code, nothing very fancy. So this is the code out here. And then what we next do is that we create the environment. So what is the environment? The environment is, so till now what we have done, we have uploaded the data. So the data is in my container. I created the cluster. So let me show also the cluster because I've already created the cluster. So it's in the workspace. You go to compute, you go to compute clusters, and you can see the compute cluster. So the compute cluster is already here. Now what we need to do is that we have to create an environment, right? Because we would require the scikit-learn library. So these are the libraries which are required to run the program. Okay, so once we do that, then what we do is that we register the environment in the workspace. Okay, now then we create the estimator. So what is an estimator? So you can think of an estimator as something which is binding the script, the compute target, and the environment together. So this is a kind of, I would say, a binder kind of a thing where it binds all the things. So we had the data set, we had the compute, we had the environment, we had the training script. So it's all binding it together. So that is what it is doing. And we are using pure machine learning here. So that is what it is. And then what we do, this is a final step. We create an experiment. So once you create an experiment, you can see the experiment here. So I've created an experiment. And then what we do is that we submit the experiment with the estimator. And now the actual thing happens. Now the actual run happens, and the running of the model happens here. So it takes a lot of time. So since this is a talk, we will not have a lot of time. So I've done it, and it is already done for you. So what I've done is that, so this, once you run it, you will have a latest run one. You can have many runs. So one experiment can have many runs. Okay. So this is a run of the experiment. So I submitted it my time 1:28, 1 hour back. So this is the experiment, and its status is completed. It has an RMSC and it has a mag step. So all these things are logged. Now I want to here pause a bit and tell you this is very good, because as a experimenter, you can log all these things, metrics, parameters, and you can run a number of times. I've done only one run. So you can do thousands of runs, and here your hyperparameters that it can be, you can change it, these will get logged and your metrics will get logged. So this is a very nice thing that is done there. And this is one of the best things here, because you can log everything. Everything is being logged for you. You can see it for your future, and it's all very integrated thing that you're doing. And now another good thing happens is that what you do is that since you created the model, you register the model in the workspace. So what happens is that once you register the model gets registered here. So that's the training part. Everything's done. So if you are a data scientist, you have done your part. fantastic, everything is done. Then the users can use your models. Some applications can use your model. So it's all, everything is in the workspace. Now the next step comes inference. That means I would pass only one row of the wine data set, because the wine data set, I should have shown you the wine data set. Sorry, I should have shown you the wine data set. Where is the wine data set? So what is happening? You trained on this whole wine data set, right? So this is a whole wine data set I should have shown you before, and you were predicting this column. So all the model is trained. Now what you do essentially, when a new row comes in, somewhere a new row would come in, and then you would pass only these values out here in yellow, and you would like to get this green, let's make it a different color, green value. So you will pass all these values here in your inference, and you will get the quality. So till this point, what we have done is that we have created the model. Now the next section is the inference. Don't worry if it is too fast for you, because I will share the code in GitHub, and also I have a blog written over here which explains all the steps. So you can read about it also. Let me just guide you through. So this is the inference part. The inference part is that you create the inference script. So in the inference script, if you look at it, it is composed of an init and a run. Init gets a model. So the model which is there in my workspace, I will get the model and I will load the model. And then what I'll do is that I will get all the data, and then I will predict the data. So this data is equal to this is something that I've just chosen. I have made it very simple. I have made it only one row. So this is the thing that I'll pass it, and I'll try to do a prediction and get this. So this is the script, inference script. And similarly, you need to have an environment, because there are certain dependencies that is required. So these are the dependencies for the inference script. And then you would have an inference config where you would combine all the code and the environment together. And then what you would do is that you would create. Now what is happening is that you have created the model, your script is ready, and now you ask all the users, all the wine lovers from all over the world, can you please use my model? But you don't want your model to just break down when thousands and thousands of users will come on. So what you would do is that deploy the model in an AKS cluster. So that's what we are doing. So in production, you will not use the dev test, because it's an Azure pass. I've just made it a dev test. So you can, here what I'm doing is I'm creating an inference cluster here, and I am deploying it and creating a web service. So this is what it is doing, and these are the steps that it does. And ultimately what it does is that it deploys the model into the inference cluster. In this code, we create the cluster, and in this code, we deploy the model to the inference cluster. You can see all these things here. When you go to compute, you go to inference clusters, my code, I have created the AKS cluster. If you go to the cluster here, you see that it's AKS cluster. You can see all the things that is there. All is done through code. I have not done anything with the portal. Everything is done through SDK. So all of it is done through code. So your cluster is ready, and then you get your endpoint, because you require an endpoint, because you've asked all over the world, can you please use the model? So this is the endpoint. We'll get the endpoint. The endpoint is exposed out here. Where is the endpoint? Endpoint is here. So this code is creating this endpoint. Now, what my application would do is that these are the keys that are required. So I'll use these keys, and then I will pass in this row that I was telling you, this row somewhere. So I just created one figure. So you can put in some values and see how it looks. And then the response is 200, and then the quality comes as 7. So this is, I think, the whole thing. But here I will take a pause before I go to the TensorFlow implementation, because the TensorFlow implementation is practically the same. Once you follow this thing, I will just make some here and there changes in the TensorFlow Keras implementation, and everything will be fine. So I will just take a pause here and request you that if you have any questions, I would be happy to take it. Any questions? Oh, there is something in the chat. Okay. 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 Thank you. Any questions, or do you want me to move to the next part? Yes. The weather, it's raining cats and dogs actually. Yeah, it's lightning. Yes, please, Carla, if you have a question. Go ahead, unmute yourself. I'm not able to hear you. How can you make this process simpler? Actually, do you know what? Meaning this is all through code. You can go through the Azure ML designer. You can do it through the Azure ML designer. It can make it simpler, but this is actually, once you set it up, it becomes a lot simpler, because once what should I say? Meaning once you yes, if you like if you write like a complicated, if you like a less complicated, then the Azure ML designer would help you to do it. But this would enable you to control everything from code, and you have full control, and it would help you in your DevOps. So in that way, it is good. But if you like a codeless environment, Azure also provides an Azure ML designer environment. So there you can also do the same thing, and it's much more easier. So that's the thing. So, but the good thing is that if you set it up, things become a lot more easier, because maybe the first time you set it up, it's all. But as a developer, as a data scientist, what I would be interested is that I would just, once everything is set up, I would just use a training script and everything's done. So this training script, everything, this is the meat of the thing. Otherwise, others are all stock standard stuff. So somebody can just create the framework and you can use it. So we can create all these things beforehand. the clusters and everything, and you can use it beforehand. So I just done it from scratch, but as far as the whole thing is concerned, this you can set it up and you can reuse this. And the best thing is that you can tier the environment anytime, repeat it a number of times, so that becomes much more easier. Okay, so if you're not a developer, that's fine. You can use the designer. That becomes a lot more easier for you. So if there is no more question, so what I would do is that maybe what I should do next time when I give is that I should give for the Azure ML designer also, maybe for those who like a codeless environment. But this has the advantage is that once you move to ML ops and everything, it becomes easier because it's highly automated and everything. So I just move to the TensorFlow part, meaning the reason I put across this TensorFlow part is because maybe you would be doing this, maybe you are doing an experiment in using deep learning with TensorFlow. How would you go about it? The steps are exactly the same, exactly the same. Only difference is I would, the code is there and it's all checked in, but what I would do is that I would just point out the differences and I just put it here. So this blog, so here there is no change. Only thing is in the create model, we'll use the TensorFlow APIs. The create the compute environment, there would be a change, and create the estimator, there would be a change. What the change is, in the model, obviously you're using a TensorFlow model, which is the Keras model. You would use a multi-layer perceptron kind of thing, which I've used, very simple one. So I'll not go into the code, but in the environment, what I'm doing is that instead of creating a new environment, something from my scratch, and I just use one of the curated environments from Azure ML, which is Azure ML TensorFlow 2.2 GPU. So this comes along with the TensorFlow things. And the estimator, what I would do, since the environment is different, I just have to replace it here. So that's the difference. Otherwise, everything remains the same. So the best part of it is that you created this whole setup and it becomes repeatable. So now you have got your data scientist who want to do deep learning. Carla, as you are saying that, meaning it's too much of code. So somebody can do all the hard work and you just have to write this part. If you prefer codeless, you can do it through codeless. But as such, the part of the data science, meaning the data scientist part, becomes very, very small here. So this part is the one that is getting changed, and a very small part out here. And in the inference part, also there is practically no change. In the inference script, there is a bit of a change, and the inference config, there is a change. Inference script, there is a very minor change because I'm loading the Keras using the Keras API. So that's the thing, the same concept of loading. And in the inference config only, there is this environment. I should have formatted correctly. It's far. So this environment will change. You can hear the wonderful thunders actually. So this is all about it from my side. So this, what I have done is try to show that how you can use Azure ML from code, full code, no use of the portal. Maybe next time I will see how I can use a designer and show you. But in this way, what is good is that the ML ops, you can tear down your environment. You can make it very much repeatable. So every time I give a demo, I don't have to do anything. I just have the same notebook and I just run it, and everything is done for me. And to tear it down, what I would do is that after the session is over, I would just go to the portal. I would just go to the portal and I would pick up the resource group and I would just delete the resource group and I just tear it down. You can do it through code even. So that becomes, you are in full control of the thing. So that becomes a great thing. And now you see the Azure ML, you have this Kubernetes service and the clusters and everything. So in short, what I would like to say is that for somebody who is a data scientist, who is it gives a very good platform to deploy your applications in production very easily, and you can scale your applications. All those hassles of where should I deploy, how should I deploy, whether it will scale or not, those uncomfortable questions that can come in data science, I think that's solved in that manner. So it gives a real peace of mind for a data scientist, because you can now concentrate on your job about the data, bringing in the data, modeling, and all those things which you really love. But all those other things like monitoring and scaling, all is taken care by Azure. So that's the thing. I will take a pause and maybe open up for more questions. And I will also share the GitHub link and the blog. So the blog is, so my blog is here. So the blog, this that's a great question. Is there a way to log metrics in a case with Prometheus, or you need to use application insights? I actually do not know. Should be. You should be able to do that. But in this code, I have just used Azure. I've just enabled. It comes by default, so that becomes a lot more easier for me. Wherever I just enabled it, so because it's all integrated, I need to check on that. That's a great question. Every time, the good thing about giving these talks is that every time I give a talk, I learn something new. So this is the AKS one, and I'll also give the TensorFlow one also. So TensorFlow one is also here. Everything is in my, so what I'm trying to do is that though I'm also putting it in dev.to, but I'm trying to do it in my blog, so that it is easier. It's in one central place. Just a second. So yes, so these are the blogs out here, and the Keras one is also here, and the GitHub also I will share. Share the GitHub also. Okay, I have not put the Keras one. I will upload the Keras one also. So all the information is there. So if you wish to have a read of it, and if you have any comments, feel free to let me know. I'll try to enable comments in my blog. I just changed my blog from Jekyll to Hugo. So I'm just trying to work on everything to make things a little bit better. So it can be a little bit uh, not baked properly, but I'm just loving Hugo more than Jekyll. It is a lot faster. So that's about it from my side. Any more questions?